So in today's lesson, I hope to introduce you to the basics of trigonometry. Trigonometry has this reputation, I think, of being this super hard section of math, when in fact, in my opinion, it's probably one of the easier sections of math, and certainly easier than a lot of the other concepts we've learned this year, like in our quadratics unit, in particular, transformations. So what is trigonometry? So trigonometry, you can see the metry bit there, and anything with metry at the back end of it as your suffix indicates measurement, right? So think like geometry, and so on and so forth. Trigono, think tri, three. So really what is trigonometry? It's an area of mathematics that aims to look at triangle measurement. And so what would we be looking at in terms of triangles? Well, if we have a triangle, well, we might be trying to measure, some of the angles in the triangle, or we might be looking at trying to determine one of the side lengths, right? So trigonometry provides us an alternate way of measuring angles and sides in comparison to maybe some of the skills that we have already. All right, so moving on. So you need to know that in today's lesson, what we're looking at specifically is I want to introduce you to the sine, cosine, and tangent ratios. And so those basic trig functions are going to apply to right angle triangles only. Okay, so now first off, what I want to talk to you about is that what we're going to be learning today about assigning some labels to triangles applies to right-angled triangles only for now. Okay, and one thing that is really important, notice the critical here, is that we learn how to properly label a triangle's sides. So let me break that down for you a little bit more. All right, so let's get down to it. So here you can see that I have a right triangle, and I can tell that it's a right triangle because it has this little square in the corner. Now we need to be careful about assumptions around triangles being right triangles because, it may just appear to be a 90-degree angle, but the diagram might not be accurate. So unless they're indicating to you specifically in the diagram that is a right angled triangle, we don't want to make that assumption. Okay, so I've labeled this as ABC. And so it's really important for you to be able to utilize the sine, cos, and tangent ratios effectively. And you can only do that if you know how to properly label your triangle sides. So I think let's look at three labels that we're going to be looking at. So there's the hypotenuse, which, some people will write hype. I usually just write H, actually. So that can just be an H. The opposite side, and that's the side that is across from the specified angle. And I'm going to talk about that a little bit more. I usually just would write that as an O instead of the OPP. I used to do that, but I think the O is just as effective. And then the adjacent side next to the specified angle forms one of the arms of the angle other than the hypotenuse. So I would label that with simply an A. That's what I'm going to do in this video. So let's get down to it. Now, all of these labels, aside from the hypotenuse, the opposite side and the adjacent side, those can change depending on which angle we're referring to. So I'm going to select a particular angle here. I'm going to select angle B, and I'm just going to indicate it by just putting a little symbol here. So this is the angle in question. And so I always start typically by labeling the hypotenuse, and that is because the hypotenuse is always the hypotenuse. It doesn't really matter which angle I'm labeling in reference to. The hypotenuse I can always locate by looking where is my right angle. The side opposite that is always the hypotenuse, right? So side opposite my right angle is always the hypotenuse, regardless. And some people will say, well, it's also the longest side. Yes, that is true, but it may not always be an obvious choice depending on the triangle's diagram. So just an easier way I find, a more consistent way to identify the hypotenuse is by looking where the right angle is and finding the side opposite that. So the next thing that I typically do when I'm assigning labels to the sides is I look for the opposite side. I usually find that that is the easiest to locate. So how do I find the opposite side? I look and see, well, which angle is it that I have in question? In this case, it's angle B here. And so then what I do is I say, well, if this is the angle, what is the side opposite that angle? So I draw it right across, and that becomes my opposite side. Now there are 3 sides to a triangle, and I found 2 of the 3 sides and labeled them. So that leaves only one side, which is the adjacent side. The adjacent side, of course, then, therefore, by default, is the one that is left over. But I can also tell which one the adjacent is, because I can say, well, it's the side next to the specified angle that's not the hypotenuse. So if this is my angle, and one of the arms of the angle is the hypotenuse, the other arm of the angle has to be the adjacent one. And adjacent just means next to. So if that helps you remember which is which. So there we have it. We have our hypotenuse across from the right angle. We have our opposite side, which is opposite the angle in question. And we have the adjacent side. Now, keep in mind that that is simply because I've referred to angle B. I'm going to draw a second triangle here, ABC. ABC. And so now, though, what I want to do instead is I want to say, well, let's label these sides relative to angle A instead. Well, the hypotenuse is still going to be the hypotenuse. That does not change. But my opposite side, now that I'm looking at angle A as the angle in question, the side that would be considered opposite to angle A would be over here. And that would leave the other arm of this triangle right here. So that would be my adjacent side, right? And again, here is my hypotenuse making one of the arms of the angle and my adjacent side being the other arm of that angle. So what I'd like you to do for a minute is I'd like you to take a look at example number 1 and try the question for yourself. I want you to label the following triangle sides as either the H, the O, or the A relative to angle X first. And then, so maybe use one color for X, and then go ahead and do the same thing for angle Z. Pause the video, give that a shot, and then come back when you're ready to take it up. All right, so I'm going to start with A, and I'm going to use, I think I'm going to use green for that. So angle X is this guy right here. And so my hypotenuse is, of course, always opposite the right angle. So this is my hypotenuse. I'm going to label it as an H. And then I'm going to look for, well, here's angle X. So opposite of angle X is going to be my opposite side, and so I'm going to label that as O. And then lastly, I only have one other side, and that side is making up the other arm of my angle, and so I'm going to label that as A for the adjacent side. So those are my labels that I would put in terms of angle relative to angle X. Now let's look at how that changes if instead I am referring to angle Z instead. So I'm going to use a different color for that. I'm going to use red. And so here is angle Z. And so my hypotenuse is not going to change. So that's still going to be right here, opposite the right angle. Right? That never changes. But now, if I'm labeling my opposite side, which side is opposite Z? Well, it's over here. So the side, this side right here is opposite for angle Z, but adjacent for angle X. So that leaves one other angle, and that is my adjacent side. So hopefully you did okay with that. Just remember that opposite and adjacent sides are not fixed, and they are reflective of the angle in question, and that the hypotenuse is going to remain the same regardless of which angle is being referred to. So now that we've talked about how to label the sides of the triangle appropriately, we're going to get into how to use the sine, cos, and tan functions that are kind of the center of trigonometry and to incorporate that into our problem solving. So we can find, as I mentioned, the angles or sides of a triangle can be found by using the sine, cos, and tan buttons on your calculator. So they're going to look something like that. And so sine is actually short form for sine, S-I-N-E, which is why it's pronounced as sine and not sin. Cos is short for cosine. And tan is short for tangent. But typically we will just refer to them as sine, cos, and tan in everyday language. So make sure that you found those buttons on your calculator, because when we get into tomorrow's lesson, we're going to be utilizing those buttons pretty closely. But in today's lesson, we're just going to learn about what they actually represent. So in math, we typically will use this, I guess it's an acronym, the acronym Sohcahtoa, to help us remember what sine, cos, and tan represent. So each of these are what we refer to as a trig ratio, and trig ratios are essentially just fractions. And so I'm going to explain what all of this means. So when the so part of Sohcahtoa is referring to sine, you'll notice that they both start with an S. Okay, and so the sine function is a ratio that relates the opposite side to the hypotenuse. So for example, I've got a little triangle drawn over here on the side. If I were referring to angle A, then I would say that the sine of angle A would be the ratio of the side length of the opposite side, there's my O, divided by the length of my hypotenuse. So for instance, if I had information about the side length here of my opposite side, right? This would be my opposite side. This would be my adjacent side, and here's my hypotenuse. If I had the actual lengths of each of those, then I could substitute those in and then find out some information about angle A. Okay, so we would say the sine of angle A would be equal to the length of the opposite side divided by the length of the hypotenuse. So let's keep going with this. So I would say that the ka part of Sohcahtoa, right here, right here, well, I want you to guess. The cosine of the angle is equal to is a ratio that relates the adjacent side to the hypotenuse. So when I go down here and I say cos of angle A would be the length of the adjacent side divided by the length of the hypotenuse. But remember, that's only with reference to angle A, not the other angles. And so lastly, if I look at this last little bit, the TOA part, well, again, you can probably guess it. The T stands for tan, and the tan is a ratio, so tan of angle A is a ratio between the length of the opposite side and the adjacent. So that's where this Sohcahtoa business comes in handy. And I would say to you, whenever you're writing a trig quiz or test, that you write Sohcahtoa at the top of your paper to remind you about what sine, cos, and tan ratios and how they relate to the sides of a right angle triangle. And again, I want to remind you that these ratios only relate and only apply if we're talking about a right angle, a triangle with a right angle in it, a right triangle. So now that I've introduced you to Sohcahtoa, I want us to practice a little bit by applying this to a question where we have some values. So I'm just, as a reminder, going to write out Sohcahtoa at the top here to remind us about what sine, cos, and tan are referring to and which sides. So I would say, so in this example, it says, write out the trigonometric ratios for angle C, given the lengths below. So this is a triangle where I'm first noticing it's a right angle triangle labeled ABC. And so the angle I want to know information about is reference to angle C. And they've already done the work with Pythagorean theorem, using Pythagorean theorem to figure out the lengths of all the sides. So presumably 2 of the 3 sides were known, and then they've done the math to make sure that that all works out. And so I would say that it is typically always good practice to label your sides in reference to the angle in question. That is always a good first step. So I'm going to go ahead and I'm going to do that in red. So relative to angle C, I can see that my hypotenuse is across from my right angle here. Here's angle C, so this 8 right here, side AB, is my opposite side, so I'm going to put an O there. And then the leftover side, which makes up the other arm of angle C, is my adjacent side. So there, I've labeled that okay. Now, the next thing I want to do here is to write out the trig ratios for angle C. So, I'm going to start by doing sine, and then I'm going to pause the video, and I want you to try the same thing for cosine, and for tangent. So for sine, I know that the sine of angle C is always equal to, well, sine is always opposite over hypotenuse. So opposite over hypotenuse. That's what Sohcahtoa tells me. And so now I'm going to go ahead and I'm going to substitute in the actual values that I have for the length of the opposite side and the length of the hypotenuse. So the sine of angle C is going to be equal to 8, and that's 8 is my opposite side, divided by root 113. And that's it, I'm done. So again, when you're asked to simply write out the ratio, you're not being asked to solve for anything, you're just asked to simply write out the expression and to substitute in any known values. So I want you to pause the video and I want you to try this for the 2 other trig ratios that we have in question, and then to come back when you are ready to take it up. Okay, so I'm going to do the cosine of angle C. Now the cosine of any value is going to be the ratio between the adjacent and the hypotenuse. And so all I need to do now is just simply substitute that in. Now one thing I should mention, adjacent side is a value of 7 and my hypotenuse has a length of root 113, which I'm going to leave in that form. I don't want a decimal here, I want the ratio, so I don't need to simplify that. But having said that, if you do end up with a fraction that can be reduced to lowest terms, you should endeavor to do that. So next I'm going to do tangent, and so the tangent of angle C is always going to be the ratio of the opposite to the adjacent side, so O over A, and substituting that in, tan of angle C is equal to my opposite side, which is 8, divided by the length of my adjacent side, which is 7. That is a fraction that I cannot reduce, and even though it's an improper fraction, I'm going to leave it in that form. So there's our introduction to trigonometry. Today we've talked about, we've talked about how to appropriately label the sides as the hypotenuse, opposite, or adjacent sides, and then we've learned about what the sine, cos, and tan ratios represent in terms of the opposite, hypotenuse, and adjacent sides. So today I'm going to give you some practice mastering that before we go on to solving for unknown angles and unknown sides.